Okay, let us speak more about refractive index now. Now, first of all, let us define what do you mean by refractive index. Now, refractive index is, the definition goes like this, dears. The refractive index of second medium, the refractive index of second medium with respect to the first is defined as the ratio of sine of angle of incidence in the first medium to that of the sine of angle of refraction in the second medium. इसका मतलब क्या है थोड़ा देख लेते हैं. Now I'm not naming any medium, okay, like air, glass, I'm not naming like that. I'm just keeping medium 1 and medium 2. Okay, if light ray enters from medium 1 and it enters medium 2, now the angle of incidence is in which medium? The first medium. The angle of refraction is in the second medium. Everyone there with me? So now let's again look at the definition. Refractive index of second medium with respect to the first medium. Now what do you mean by this? With respect to means from which particular medium the light is coming. Okay, so if the light is traveling from air to glass, the light ray, and I will have to say in this particular terms, refractive index of glass with respect to air over here. So here also I will be saying refractive index of medium 2 with respect to medium 1 is defined as sine of angle of incidence upon sine of angle of refraction. Yes, that is what is the definition. See, refractive index of second medium with respect to is defined as ratio of sine of angle of incidence in the first medium and the sine of angle of refraction in the second medium. Okay, so now if you can see, I give here we spoke about one formula for refractive index. Let us go to the next, how the refractive index is dependent on the speed of the light. So we have one more formula for this which goes like this: mu, that is the refractive index, is speed of light in vacuum upon speed of light in a medium. Now we all know that the speed of the light in air and vacuum is more or less the same, or for our easy calculation purpose we will be taking it the same, that is 3 into 10 raised to 8 meters per second. Hence here this formula goes like this: mu is equals to C upon V. Okay, now here in this table, you will see this table is there in the textbook. I have not taken down all the values, only some of the values I have written. Don't worry, you need not have to by heart these values. These values will be given to you all, or either they will be given asked for you all to calculate with the, of course, required information will be given to you all. So now here, understand this, dears. Why I have written this table over here is to understand this one topic: conditions for no change in the direction of light. Okay, now when can we say that in spite of light traveling from one medium to another medium, there is no any refraction taking place, or the light ray is passing undeviated? So now if you remember in the very first video that we made of for this particular chapter, in that I had already spoken the third condition when light ray travels, when the light ray is incident normally. Okay, when the light ray is incident normally, light ray travels, there is no any deviation or there is no any refraction, light ray goes undeviated or it passes in a straight line. The second medium, the second condition says that if both the mediums have same refractive index. So here you all might get confused. If you can see, there are these two mediums, methylated spirit and ether. Yeah, both of them are having similar refractive index. So in this case also, if both of them are having same refractive index, light ray will pass without any deviation. Very, very important concept, asked many a times in the exam. Okay, now the whole purpose is, again the question comes, why are we studying refractive index? Why? As I spoke in the previous video also, here I have put one example. Now this is the value of refractive index of diamond. We have taken in the textbook, you will see this, it is the last particular substance that is given in that table. Refractive index of diamond is 2.4. Now what do you mean by this? As I rightly previously said, that this particular number, or rather these numbers that we are seeing over here, okay, what does this particular value convey as an information? It conveys, see this, light travels in air 2.4 times faster than that as it travels in diamond. Are you all there with me? So iska, once again pay attention, this particular value of refractive index will give me the information that compared to that particular medium, if I have, now we all know the refractive index of glass is 1.5. So which means what? In air, the light ray is going to travel 1.5 times as fast as that it will travel in glass. Or in another way, what we can say, when light ray travels from air to glass, what is going to happen? Its speed is going to reduce by how many times? 1.5 times than the speed in air. I hope I am able to understand that is light of in travel is 2.4 times faster in diamond. Again, this is a question asked in compulsory questions. This statement is given to you all and it is asked, what do you mean by this? Okay. So now we will continue with this one more concept in this. Okay. This concept called as absolute refractive index. Now let us understand this, students. See, if light ray is traveling from air to glass, okay, and here I say air, diamond, okay, and let me take 2-3 more examples. In this I am putting kerosene, petrol, then I say methylated spirit and glass, and let us take one more example, glass, and what to take, again petrol let us take, okay, it doesn't matter, any example we can consider. Now what is the difference that in these cases, just pay attention, here the light ray is traveling from air to glass, okay, air or vacuum, we can keep anything, okay, doesn't matter over here, we can keep air or vacuum, both of them are the speed of the light in both the cases is same only. So now whenever light ray travels from vacuum or air in a particular medium, here the medium is glass, here the medium is diamond. So this particular value I can write it as mu g only, here I can write it as mu d only, okay. That means that respect to medium, if I don't write, then also it is okay. Everyone is understanding this? But whereas for these cases, how will I write? I will write it as refractive index of petrol with respect to kerosene. Here I will write it as refractive index of glass with respect to methylated spirit. For this I will write it as refractive index of glass with respect to petrol. Okay. So here this particular value where the with respect to medium we need not write, or we don't write rather. Why we don't write? Because the light ray is traveling, if the light ray is traveling from vacuum or air in a certain medium, we will say it as absolute refractive index. And in these cases, when there are two different mediums or any particular mediums, then we will call it as relative refractive index. How to remember? There are two mediums, there is some relation, that therefore it will be called as a relative refractive index. And if there is other than air or that is just air or vacuum is there, then we will call it as absolute refractive index. I hope you all understood this video. We'll continue in the next one. Thank you.